right? Just wanted to confirm whether you guys can hear me. So let me start share the screen. Okay. And then record. I want to record this class because I'm going to paste it on the on YouTube, because this is going to be a very important lesson, right? The only thing that I'm going to not to include today, this is going for grade 12, right? I'm not going to include the compound angles. So I will do another on the next. I will do another lesson. I will just post it on YouTube, where I will just add some examples regarding the compound angles, right? Today I'm not going to include any compound angles, all right? Okay, so with the general solution, I'm going to start small. I'm going to start with the very basic questions where they ask us to find the general solution. I will do sine of x is equals to, let's say, 0,35, and then they ask us to find the general solution, right? And then I will do tan of 2 tan of theta is equals to or minus 1, 2 tan of theta minus minus 5 equals to 0. All right. So these are the two general solutions that I'm going to do first. These are straightforward ones. All right. So let's look at the first one here. This first one here, guys, the first thing that you do when you are to find the general solution, this one is already in the simplest form, right? There is no simplification that we need here, and then we just need to find our general solution, right? So the first thing is to find the reference angle. That is the first step of the general solution. You find the reference angle, right? So what is the reference angle? The reference angle, you come here and say sine second function of our ratio there, which is 0,35. So can someone quickly give me the answer here?
20,48.
20,48 degrees, right? 20,48 degrees. So this is our first solution, right? This is our first solution. So this is our reference angle. Sorry, this is our reference angle. So now we are going to write the general solution. Because this one was positive here, we ask ourselves, sine is positive on which quadrant? Sine is positive on the first and the second quadrant. All right, sine is positive on the first and second quadrant. Do we have anyone with a challenge with that, identifying whether sine, cos, or tan is negative or positive on which quadrants? Is there anyone with who has a challenge on that? Okay, it means that we all understand our cast diagram, right? Okay, so on the first quadrant, we know that this 20 degrees is already on the first quadrant. So we will write our general solution. Our general solution, we take this angle as it is. So it's x there. So it's going to be x is equals to our reference angle, because it's already on the first quadrant, 20,48 degrees, plus the period of the sine graph. Period of a sine graph and the cos graph is 360. So it's going to be 360 degrees dot k, and then k is z. All right. So that is our first solution. All right. That is our first general solution. All right. K is an element of integer. All right. And then we go to the next question, or to the next solution, general solution, which is on the second quadrant. And on the second quadrant, we know that second quadrant is 180 degrees minus what? Minus the reference angle. Right? So it means that here is going to be x is equals to 180 degrees minus 20,48 degrees plus 360 degrees dot k, and then k is z. So this one becomes 159,52 degrees plus 360 degrees dot k, and then k is z. So there is our two general solutions, right? So they will mark for the reference angle the general solution, the first general solution here, and the second one. So this one would have got 3 marks, right? This one is very straightforward. It will have got 3 marks. And then sometimes they will say deduct 1 mark for the learner not to write the right thing here, right? This 360.k and k is z. They will deduct a mark if you don't write it, right? So let's go to the next one. The next one is going to be this one. Do I have any questions on the first example here? Do I have any question on the first example here?
No.
Okay, thank you. So let's go to the second one. The second one, guys, the first thing that we need to understand is that to find the reference angle and the general solution, this trig ratio here has to be on its own side, right? So we'll take everything to the other side. So it's going to be, we're going to start by simplifying, which is going to be 2 tan of theta is equals to -5. Then we divide by 2, we divide by 2. Our tan of theta is going to be -5/2. So now we are done. We've written our things in a proper way, right? It's starting with the trig ratio, all right? So now let's find our reference angle. When we find the reference angle, we don't include this negative, all right? So the reference angle is going to be tan second function of 5/2. So what is tan of 5/2?
68,20.
What? 8?
68,20.
68 or 58?
68.
Okay, 68,5 degrees.
No. 20.
What?
2. 2.
20. Okay, 20, 2 degrees. So there we are. That is our reference angle, right? Our reference angle is 68,2. So now we come and ask ourselves, here we had a tan that was having a negative. So when we find the reference angle, we had a negative here. We don't come here and check our things here. We check when we had our trig ratio on the subject of the formula. What was the ratio on the right hand side? The ratio on the right hand side was a negative, right? So we ask ourselves, where is tan negative? Tan is negative on a second quadrant and a fourth quadrant, right? So tan is negative on a second and fourth quadrant. So we are going to write our general solution. We are going to say what? We are going to say theta is equals to, on the second quadrant we know that is 180 degrees minus what? The reference angle 68, 2 degrees plus the period of a sine and cos graph is 360, but the period of only tan graph is going to be 180. So we'll say 180 degrees dot k, and then k is it. All right. So it means that our theta is going to be what? It's going to be 1, 1, 1, comma 8, right? Is it correct? Yes, I think it's correct. Yes, it's correct. Plus or degrees plus 180 degrees dot k, and then k is it. So there is our first general solution. Right? There is our first general solution. So let's go to the next general solution. The next one is going to be on which quadrant? On the fourth quadrant. We know the fourth quadrant is 360 minus. So the second one is going to be theta is equals to 360 degrees minus 68 comma 2 degrees dot plus 180 degrees dot k, and then k is it, and then which means that this one is going to be 291 comma 8 degrees plus 180 degrees dot k, and then k is it. So that is our two general solution. This is the second one, this is the first one. All right, so marking here, to make tan subject of the formula here should be a mark, reference angle a mark, and then the first general solution and the second general solution. So this one would have got 4 marks. I will clear them.
Yes, sir.
Okay, so that is the very first things that are straightforward on the general solution. All right, these are the straightforward general solutions. All right, So we will go to the next one, and then this one I consider that I believe that we all understand this general. Yeah. Do I have a question? Okay, I don't, right? Okay, so let's go to the next one. Let's go to the next example. The next example is when we are given 2 cos of theta, or let's start with this one. No, let's start with this one. Let's start with the one that I don't have to simplify first, right? Let's say I'm given cos of 2 theta, cos of 2 plus 2 theta plus 20 degrees, 2x plus 20 degrees. And then I'm not going to do simplification again on this one. I will say is equals to 0, 3, or negative 0, 3, negative 0, 3. So this one again, guys, because our cos is already subject of the formula here, and then we've got a number there, it means that there is no need for us, grade 12, I'm talking about to grade 12 more this time, there is no need for you to expand this compound angle here. You just leave it like this, you are done. It's already in its simplest form. So you just find our reference angle. So the reference angle is going to be cos second function of what? Of 0, 3. All right. So what is cos of 0, 3? What is cos?
72.54.
72.54 degrees. So that is our reference angle. All right. So now we go and find our things in the correct quadrants. Right. So cos is negative on which quadrant? Cos is negative on the second and third quadrant. Right? So on the second and third quadrant, it means that on the second, we know that is 180 minus. So guys, the angle, you write it as it is here. Right? You write it as it is there. So you come here and say 2x plus 20 degrees is equals to, remember the quadrant is the second quadrant. So second quadrant is going to be 180 degrees minus the reference angle 72.54 degrees plus 360. Remember the period of cos graph is 360 degrees dot k, and then k is z. So it means that we are going to have what? We are going to take the 20 to the other side. So it's going to be what? It's going to be 2x is equals to, when it subtract these two, is going to be what? It's 107.46. And then the 20, when it goes to the other side, it's going to be a minus. It's going to be minus 20 degrees plus 360 degrees dot k, and then k is z. And then if I subtract the 20 there, it's going to be 2x is equals to is it 87? Yes, 87.46 degrees plus 360 degrees dot k, and then k is it. Then remember, our general solution at the end should be x is equals to. All right, so we'll have to divide by 2. We will have to divide by 2. So our x will be, what is 87 divided by 2? It's 43 comma what? It's 43 comma what?
73.
73 degrees plus 180 degrees dot k, and then k is it. So that is our first general solution. All right, so this angle, guys, when you write the general solution, you take it as it is. All right, so let's go to the next general solution. So the next one again is going to be on a third quadrant. So on a third quadrant, I will start at the beginning is 2x plus 20 degrees is equals to, the third quadrant is 360 degrees minus, uh, or third
No,
quadrant, right?
sir.
Is third quadrant, sorry, yes, is third quadrant. So third quadrant is 180 plus, right? It's going to be 180 degrees plus the reference angle, which is 72.54, then plus 360 degrees dot k, and then k is it. And then I will take, it's going to be 2x, and then this minus that is going to be 252. 3.54. And then when you take the 20, it's going to be minus 20 degrees plus 360 degrees dot k, and then k is z, and then 2x will be what? Will be 232.54 minus plus 360 degrees dot k, and then k is z. So if I divide by 2, divide by 2, divide by 2, so it's going to be x is equals to, what is this one? Is 116, comma, what? 27.
27.
27.
Yes, plus 180 degrees dot k, and then k is z. So there is our second general solution. So I will clear again with this one.
Yes, sir.
Sir.
I don't have any question, right? Okay, thank you. So now let's go to the one that we need to factorize, right? So let's say they've given us 2x, sorry, 2 sine x, 2 sine x, 2 sine squared x is equals to cos sine x, or let me see, cos x minus 1 plus 1, right? So, or should I, okay, it's fine, I can start. Okay, let me start with the straightforward one. This one will come to it later, all right? Let me start with this one. Let me start with sine x, 2 sine x plus 3 sine x minus 1 equals to 0. All right, sine squared x here. So with this one, guys, you can see you've got your quadratic, right? You can see you've got your quadratic. And you guys, I know you hate to factorize. You don't want to learn to factorize because you always tell me we know we use quadratic, right? Okay, so this one you can use your quadratic, right? You can use your quadratic. You will consider this one as what? You consider it as it is 2x squared plus uh, plus what? Plus 3x minus 1 equals to 0. You will consider it as this one because you will say sine x, you are taking it as if it is x. So if you use a quadratic, remember it's going to be what? It's going to be x is equals to negative b, which is negative 3, plus or minus the square root of 3 squared minus 4. Our a is 2, our c is negative 1, and then over 2 into 2. So what is going to be the answer there? Sorry, I'm sorry for that, guys. You just forgive me for that, right? Am I still sharing? Yes, I believe I'm still sharing. Yes, I believe I'm still sharing. Okay, so if I've got something like this, our a is 2, all right? So what is going to be the solution here? Can someone punch the calculator and give me the solution quickly?
Getting decimals, eh?
It's in decimals, it's fine.
0.28.
X is 0.28 or what?
Negative 1.78.
Negative 1.78. So this one, that was the only option. We were supposed to use our quadratic, right? We were supposed to use our quadratic. So here, because we cannot factorize, we're supposed to use our quadratic. So you use your quadratic, and then now you will come here and say, remember, this x was what? Was supposed to be sine, right? You change x with sine, right? So you're going to use, say, sine of x. Sine of x is equals to 0.28, or sine x is equals to negative 1.78. All right, so those ones, it means that you are going to find two general solutions for this one, and then if possible, two general solutions for this one. But in this case, this one here, there is no general solution. Why there is no general solution? I told you guys, know your sine graph and your cos graph, right? So your sine graph and your cos graph, your sine will start here, This is your sine graph, right? This is your sine graph. So the sine graph starts here at what? At 0 and 0. This is sine x, right? Let's say this graph is sine x. So you can see that the graph of sine here at the turning point here is at what? Is at 1. And then at a lower turning point here is at -1. All right, is at -1. The graph of sine will never be below -1 and will never be above +1. All right, so this one here, because it's below, is less than -1, it means that it is not valid. All right, it is not valid. You cannot find the reference angle for that one. If you punch into the calculator, it will straight away give you an error. Right, it will straight give you out an error. All right, so it means that that other one we are not going to include it, right? So if you don't want to learn that, then it's fine. You can try to find the reference angle sine second function of 1,78 is going to give you undefined, right? It's going to give you undefined. So it means that the general solution that we'll try to find is going to be 428, right? So 0,28 is on the is positive, right? So I will find my ref angle here, which is going to be sine second function of 0,28. And then what is our reference angle?
16,26.
16,26 degrees. So it means that our general solution is going to be x is equals to 16,26 on the first quadrant plus 360 degrees dot k, and then k is z. And then the other one is going to be on the second quadrant, so it's going to be x is equals to 180 degrees minus 16,26 degrees plus 360 degrees dot k, and then k is z. And then this other one is going to be what? It's going to be 163,74 degrees plus 360 degrees dot k, and then k is z. So there is our two general solution, right? There is our two general solutions, right? This one couldn't take us anywhere, right? Although sometimes it will be able to take us somewhere. Unfortunately, in this case, it didn't take us anywhere, right? So that is how we're supposed to do that general solution there. Right, so if you have got something like this that looks quadratic, it means that you can go straight forward to do your quadratic, right? You can solve it using quadratic equation if you can't factorize it. But if you can factorize, you'll just factorize and solve, right? So let's come back to the one that I gave you here. Right, let's come back to the one that I gave you here. So this one here, let me rub the sine graph here, and then let's try to solve this equation here. Right, let's try to solve this one here. Okay, this one, guys, you will have to remember about simplification. Right, okay, so you will try to put it together. So it's going to be 2 sine squared x minus cos x minus 1 equals 0. So where is the challenge with this one? The challenge with this one is that I'm dealing with a cos and a sine, and a sine is a squared, a cos doesn't have a squared, right? So something that doesn't have a squared, guys, you cannot play with it. You can't do anything with this one. It's on its simplest form, right? There is nothing you can do with cos of x, right? The only thing that you can try to work with is this one here. This one here, you can work with it. How can you work with it? You can work with it using a square identity, right? You use a square identity. You know that sine squared of x plus cos squared of x equals to 1. That is a square identity, right? So you know that cos squared of x equals to 1 minus sine squared of x. From the square identity, I just took the sine to the other side. Or if I want to make sine subject to the formula, I can take cos to the other side. So it's going to be what? It's going to be sine squared of x is equals to 1 minus cos squared of x. So those are the square identity. All these ones, we call them square identity. They're coming from the identity that we know. Cos squared plus sine squared is 1. All right. So it means that we can always have these kind of things, right? We can always have those, right? So I'm going to use those. So I'm going to change this one here. I'm going to change this one here to sine squared x to be what? To be cos, so that I will have a cos and a cos. That way I will be easily able to work with it. All right. Remember, if you need to change one, if you've got a sine and a cos and you need to change one to be the same thing, if there is a one with a squared, it means that you can change it using a square identity. All right. So let's do it. So it's going to be 2, and then sine x. Remember, sine x is the same as 1 minus cos squared, right? So it's going to be 1 minus cos squared x, and then minus cos x minus 1 equals 0. All right. So it means that's going to be 2 minus 2 cos squared x minus cos x minus 1 equals 0. All right. So if we arrange this in a correct order, it's going to be what? It's going to be negative 2 cos squared x.
Sir,
Yeah.
you can see your screen.
What? You can see my screen.
Can see
All of you can't see my screen. I think your network, Innocent, is not good. I can't hear you properly also. Let me ask someone. Let me just pick anyone
Sir,
to
I can
ask.
see your screen.
You can see it properly, right? Innocent,
Yes.
I think your network is not good there. Just shift somewhere where there is a better connection.
Yes, sir.
Okay. So this one here, it means that we can rearrange it. So it's going to be negative cos squared, and then minus cos x, and then negative 1 and 2 is going to be plus 1 is equals to 0. All right. So because this one and this one, they will give us a positive 1. All right. So it means now we need to factorize. So before I factorize, I will divide everything by negative 1. All right. Divide by negative 1. Remember, when you add to factorize and a is negative, you can divide by negative once if we have equated with 0. Right. If it's an equation, not an expression. All right. Okay. So now it's going to be what? Now it's going to be 2 cos square x plus cos x minus 1 equals 0. So now we need to factorize, right? Now we need to factorize. So when I factorize here, I told you that you can use quadratic if you can't factorize, right? If you can't factorize, you are allowed to use quadratic. But if you can factorize, then you can factorize. So it's going to be 2 cos x, and then cos x, and then 1 and 1. So the positive will be this side, so we have plus 2x, and then the minus this side, and then equals to 0. All right. So it means that each factor is 0, right? So it's going to be 2 cos x equals to 1, or cos x equals negative 1. All right. So when I divide by 2, our cos x will be 1 over 2, or cos x will be negative 1. I'll clear with this one. Guys,
Yes,
I'll
sir.
go. Okay. So the take home tip here is that once you've got sine and a cos, and then one of them is squared, all right, one of them is squared, then you can use a compound, and you can use a square identity. All right. Once one of them is squared, you can use a square identity. We can only use the square identity once one of them is positive. All right. Once one of them is a squared, one is not a squared, right? If one of them is a squared, one is not a squared. That is where we use a square identity to make sure that we've got the similar trig ratios, right? To make sure that we've got similar trig ratios, all right? So there we are. So it means that now we are going to the next one. We are going to, let me find the general solution for this one quickly. So this first one, I'll find its reference angle. So the reference angle is going to be cos second function of 1 over 2, which is going to be the special angle 60 degrees, right? So it means that on the first quadrant is going to be x is equals to 60 degrees plus 360 degrees dot k, and then k is z, and then the other one is going to be x is equals to the second quadrant, right? Second quadrant is going to be 180 minus 60. So let me write it: 180 minus 60 degrees plus 3 is the fourth quadrant, right? Is the fourth quadrant, sorry. Cos is positive on the first, on fourth quadrant, right? To be 360 degrees minus 60 degrees plus 360 degrees dot k, and then k is z, which will end up being x is 300 degrees plus 360 degrees dot k, and then k is z. So there is our general solutions, right? There is our general solutions. So with this one here, we are done, right? Okay, so let's find this one here. This one was going to be the ref angle. The ref angle x is going to be the ref, not x, but the ref angle. The ref angle is going to be, the ref angle is going to be cos second function of 1. Remember, on a reference angle, we don't use a negative. So what is cos second function of 1? Is it a 0 or a 90? I think it's a 0. And then it means that it was a negative. Negative is on which quadrant? Negative is on the first quadrant, and the negative is on cos is second and third, right? Second and third, sorry. So it's going to be x is equals to, on the second quadrant, remember second quadrant is 180 minus, so 180 degrees minus 30 minus 0 is going to stay the same, right? Plus 360 degrees dot k, and then k is z. And then the other one is third quadrant. Third quadrant is going to be 180 plus 0. So 180 plus 0 will remain as 180. So for this one, I will just write it like that. I won't have to write another one, because it's 180 minus and 180 plus, which is the same thing, because plus 0 and minus 0, it doesn't add value or subtract value, right? So there we are. That is our 3 general solutions. So it's this one, and that one. And then there will be marks for factorization here and having it in a quadratic form, factor values of x here. So you can see it will have around 5 marks, right? To have around 5 marks. Okay, the 6 mark, remember you use the square identity here, to use a square identity and change that one. So it will have around 6 marks there, right? To have around 6 marks. This is gonna come for both grade 11 and grade 12, right? So remember, trigonometry for grade 11 and 12, what is the difference? The difference is what? The difference is a compound angles, right? Compound angles and double angles. That is the only thing that the grade 11s don't do. When we come to 12, we'll also talk about the double and compound angle. So I'll do more example about those tomorrow. For now, I'm not going to include double and compound angles, right? So this is what they would expect you to do, right? This is what they would expect you to do. So now let's go to the next one. The next example, I'm going to have 3 sine x equals 2 cos x, and then they ask us to find the general solution. They ask us to find the general solution on this one. So on this one, guys, this one is different to what? This one is different to, if they ask us to find the general solution of sine 2x plus 20 degrees is equals to cos what? Cos 3x. These two things are not the same, right? These two things are not the same. You can see that the angles here are different, and then the angle here is the same, right? So let me just write plus 10. Let me just add plus 10 here, just to emphasize to you that these two things are different. The other one plus 10, let me rub it, and then I add plus 10. I just want to emphasize that these things are not the same, right? 3 sine x plus 10 degrees, and then on the other side is equals to 2 cos x plus 10 degrees, right? So these two things, guys, this number 1 and this number 2 are not the same. So we are not going to approach them the same way. There's no way we can approach them the same way, all right? So what do we do with this one? This one, because we've got the same angles there, all right? but different trig ratios here, right? So what do we do with this one? This one, because it's the same sine and cos, it means that I am going to divide both sides by cos. Remember, I divide both sides by cos. Why do I divide both sides by cos? So that I will have cos and cos cancelling each other, and then sine over cos is going to change to be tan, right? I'm going to change to divide both sides by cos, and then after that, the other side cos and cos will cancel. The other side sine over cos will be changed to be tan. All right. So that is the first step here. The first step. Okay, let me write it. It's going to be 3 sine of x plus 10, and then equals to 2 cos of x plus 10 degrees, right? So the first thing is going to divide by cos. Whether sine is on the other side or on the other side, if you have got the same angles, you divide by cos, so that because you need sine over cos, that is your target, right? You're targeting to have sine over cos, and then this one will change to one trigonometry, it will be tan, right? So I will divide by cos of x plus 10 degrees, right? And then divide by cos of x plus 10 degrees, right? So cos of 10 plus x plus 10 and cos of this one will cancel out, and then sine over cos will change to be tan. So it's going to be what? It's going to be 3 tan x. It's going to be 3 tan x. So it's going to be 3 tan x equals 2, right? And then after that, we can easily divide by 3. We divide by 3. So our tan x is going to be 2 over 3. Are we all clear there? Rusa?
Yes, sir.
Yes, sir.
Okay, we're clear, right? Okay, so once we have got tan of x equals to this one, that's when we can work out our general solution. We've got tan x. Oh, it's not x, sorry. Our angle there. Why are you saying we're clear? Why did I write tan x there? I've made a huge mistake, right? I've made a huge mistake because our angle is not x. Our angle is what? Our angle is x plus 10. Our angle is x plus 10 degrees, right? It's tan of x plus 10 degrees is equals to 2 over 3, all right? So I've made a huge mistake there. I hope you are not going to do it, right? You are not going to make that mistake, right? So now you have got our trig ratio equaling to ratio. So it means that I'm going to find our generals, our reference angle. So our ref angle is going to be what? Our ref angle is going to be tan second function of 2 over 3. So what is the reference angle? What is the reference angle?
33,69.
33,69 degrees. So that is our reference angle, right? That is our reference angle. So now we are going to write our general solution. So tan, it was positive here. Tan is positive on the first quadrant. So it's going to be x plus 10 degrees is equals to, on the first quadrant, it's going to be 33,69 degrees plus um, 180 degrees dot k, and then k is z. So it means that's going to be x is equals to, if I take 10 to the other side, it's going to subtract, it's going to be 23,69 degrees plus 180 degrees dot k, and then k is z. And then we are going to the next quadrant, which is going to be what? Which is going to be the third quadrant, right? Because our tan is positive also on the third quadrant. So it's going to be x plus 10 degrees is equals to, on a third quadrant, it's going to be 180 degrees plus the reference angle plus 180 degrees dot k, and then k is z. And then it means that this is going to be 123, right? 123,69. When we add 10, it's going to be x. We subtract 10, it's going to be 113, I'm lying here. I'm lying. I think it's going to be 103. Okay, so let me just do everything. So it's going to be 213, 69 plus minus 10 plus 180 degrees dot k, and then k is z, and then it means that's going to be x is equals to 203.69 plus 180. Don't forget to decrease there, right? Decrease dot k, and then k is z. So there is our second general solution, right? So this is only done when the trig ratios are the same. I mean the angles are the same. If the angles are different, you can't do that. Okay, so let's look at this one where we've got a sine and a cos, and then the angles are not the same also, right? The angles are not the same also. All right, so this one here, we do a cofunction. All right, we do a cofunction. So what is a cofunction? I'm going to show you a cofunction. Let's say I've got a triangle here. Let me rub here. I've got a triangle, and then on my triangle I know one angle. All right, I know one angle. So let's see. I know this angle there. I know that angle there. So let's say I know that here is 40 degrees, right? And then I know that here is P, and there is K, and here is T. All right. So it means that now I'm going to find my things in terms of P, T, and K. All right. And here is 90. All right. So if I am to find sine of 40 degrees, sine of 40 degrees is going to be what? Sine is opposite over hypotenuse. So it's going to be P over T, right? And then cos of 50. Now let's talk about 50. What is 50? So if you use the sum of angles on a triangle, although you were not given here, you will know that here is going to be what? Remember, it's 90 and 40, and then this unknown here. So it's what? It's 180 degrees is equals to 40 degrees plus 90 degrees plus the unknown. The unknown, I'm just using u, and then it means that to solve for the unknown angle, I'm going to take everything to the left. So it's going to be 180 degrees minus 40 degrees minus 90 degrees is equals to the unknown angle. All right. So it means that if we subtract here, we'll end up having a 50 degrees. All right. A 50 degrees is going to be our unknown angle. So our angle here, we know that is 50 degrees. Right. So now we know sine of 40. What is cos of 50? Cos of 50 degrees. Cos of 50 is going to be what? It's going to be adjacent to 50. The length which is adjacent to 50 is this one. Over the hypotenuse is that one. So cos of 50 is also the same, is also P over T. So you can see that 50 and 40, they are the same thing, but in a different ratios. They are not the same. What are those angles? Those angles, we call them cofunction. What are cofunction? Cofunction are the angles that gives us 90, right? Angles that gives us 90. So for example, if I've got sine of 25, right? If I've got sine of 25, I know that is equals to cos of what? Cos of the other angle that I will add with a 25 and get a 90 is equals to cos of 90 minus 25 is 65 degrees. So if you punch this one and check the answer, and also punch this one and check the answer, they will be the same thing. We call them co-function, right? We call them co-function. So when we talk about co-function, guys, if you want to write them straightforward in a way that it will help you with even with unknown angles, like when the angle is x in these scenarios here when we're dealing with general solution, right? So what you know is that sine of 20 is equals to cos of 90 degrees minus 20 degrees, right? So sine of this angle is equals to cos of 90 minus the same angle, right? So this is the same as cos of 90 minus 20 is 70 degrees, right? So sine of 20 and cos of 20 is the same thing. I will go there.
Yes, sir.
Yes, sir.
Okay, so this one here will again come to it, right? Let me just give you another example of the general solution, right? This one we are coming to it. I think it will be the last one. So let me just give you another example, right? Another example is when we are given sine of 2x minus 20 degrees is equals to sine of x plus 15 or 25 degrees plus 25 degrees. Right, and they ask us to write the general solution. Right, they ask us to find the, or let me use the bigger number here because I want to show you something also. Right, I want to show you something also. Let me just give you 3x here. Let me give you 3x so that I will be done with this one. Right, so that I will be done with this one. Okay, so let me use 5x. Yes, let me use 5x plus 20. Let's say they gave that. Remember, it's the same as sine and sine. All right, before I do anything, I want to show you something. All right, if you have got sine second function of sine of 30 degrees, can you do this on your calculator and give me the answer? What is the answer? Equals to 30, right? It brings us back to this one, right? It brings up back to this one, to the angle that is inside, right? So if you are given something like this, already it's the trig ratio and the trig ratio. What's inside here is something else that we cannot really say we are familiar with. So we are not going to play with something that we are not familiar with, or something that we see that we are not going to be able to solve them on our standard, right? So what we do here is to find the reference angle straight away. The reference angle. So the reference angle is going to be what? It's going to be sine second function of what? Of sine of 5x plus 25 degrees. This is when the reference, there's trig ratios this side and the trig ratio that side are the same, right? This is when the trig ratios are the same. So straight away, I told you that sine second function of sine of something is going to be the same thing that is inside there. So it means that in this case, the answer that is here is going to be, the solution is going to be this one, right? So the solution here is going to be 5x plus 25 degrees. So that is our reference angle. Are we clear? Does it need more
Yes,
extra?
sir.
Okay. So it means that now to find the general solution, we are going to use this as a reference angle. All right. So because it was positive here, it was not a negative. It means that we're going to ask ourselves, sine is positive on which quadrant? On the first and second quadrant, right? So on the first quadrant, it's going to be 2x minus 20 degrees is equals to this other one, what do we call this? The reference angle as it is, right? So it's going to be 5x plus 25 degrees plus 360 degrees dot k, and then k is z. All right, and then now we are going to take the 20 to the other side, so it's going to be 2x is equals to 5x plus 45 degrees, and 5x will come to the other side, right? Sorry, 5x will go to the other side, right? It's going to change sign to be minus 5x equals to 25 degrees plus 20 degrees plus 360 degrees dot k, and then k is z. All right, so it's going to be negative 3x equals to 45 degrees plus 360 degrees dot k, and then k is z. So when we divide by negative 3 by negative 3 by negative 3, so the answer is going to be x is equals to negative 15 degrees minus this one is going to be 120, yes, negative 120 degrees dot k, and then k is z. So that is the first general solution there. All right, and then the second one again is going to be where sign is positive is on the second quadrant. So I will copy the angles again. So it's 2x minus 20 degrees is equals to the reference angle, which is 180 180 minus, because it's on the second quadrant, right? So it's going to be 180 degrees minus the reference angle, which is 5x plus 25 degrees, and then plus 360 degrees dot k, and then k is z. All right, so this one is going to be what's going to be 2x minus 20 degrees equals 180 degrees minus 5x minus 25 degrees plus 360 degrees dot k, and then k is z. So it means that I'm going to take the 5x to the other side, so it's going to be 2x plus 5x equals to 180 minus 25 is 165. 155, sorry, 155 degrees, and then the 20 is going to change to be plus 20 degrees plus 360 degrees dot k, and then k is z. So this one's going to be 7x is equals to 177 degrees plus 360 degrees dot k, and then k is z. So we divide by 7, we divide by 7, we divide by 7. So what is our x? What is 177 divided by 7?
25,28.
25.
25, 2.
8.
29. 29.
29. Okay, Innocent, you didn't round off well there. Did or did they who made a mistake? I'm sure you Innocent might be the one, because 28, the one who said the lower one, I believe is the wrong one. Innocent, did you round it correctly?
I don't know, sir.
Okay. What is the answer? 2 what?
Isn't it 175?
Eh?
On 177. Isn't it supposed to be 175?
175.
So I'm also getting 175.
Okay, yes, I think it was yes, I made a mistake there. Sorry, it was not 177, it was 175. I don't know what was I thinking there. Okay, so when we divide 175 by 7, it gives us this answer 28.
25.
25 exactly.
Yes.
Oh, okay. So I'm sorry about that, right? I'm sorry for that. Okay, so it's giving us 25. Okay, 25 degrees. Thank you very much for that, right? 25 degrees, and then 360 divided by 7 was the answer.
51,43.
51,43 degrees. Okay, dot k, and then k is z. All right, and then k is z. That is our general solution. All right, and then we are done with the general solutions here. In this case, if you have got a sign this side and a sign that side, that is pretty straightforward, right? So we are going to our thing here. We're going to our question here. The main question is this one, right? So I believe this one we all understood it, right? So let's come to this one now. Let's come to this one now. If you are all listening and you all understand what we're doing here, there's no one who's going to get any general solution question wrong from today, right? There's no one who's going to lose this marks for general solution, right? Maybe to apply it, I'll also teach you how to apply it. What is the meaning of the general solution? Why do we need general solution? All right, I will show you that also, right? Because I know some of you just know that, okay, it's 360 plus, it's plus 360 dot k, and then k is z. You don't even check what is the k is z mean, and then what is the factor k does, right? Okay, so with this kind of question, guys, because let me say here we've got minus 10 also, minus 10 degrees also, so that it has got something extra so that you can see everything, right? So because what I've told you now is that sine of 20 is equals to cos of 90 minus 20. This is what you know, right? This is what you know. I've just told you now, right? So we call it a cofunction to change sine to be cos, right? So in this question, guys, we are going to change cos to be sine, or someone can decide to change sine to be cos, right? So for me, I prefer to do my things exactly how they give me, right? So I'm going to change this cos to be sine, right? Someone can decide to change this sine to be cos, it's still fine, right? But for me, I'm going to change the cos on the right hand side to be sine, right? So I know that sine of 2x plus 20 degrees is going to be the same as what? It's going to be the same as sine of 90 degrees minus 3x minus 10 degrees, right? There we are, right? It's supposed to be 90 minus, right? So when I simplify, there is going to be sine of 2x plus 20 degrees is equals to sine of 90 degrees minus 3x plus 10 degrees, all right? So what is the solution there? It's going to be sine of 2x plus 20 degrees is equals to sine of 90 plus 10 is 100 degrees minus 3x. So there it is. Now we've got sine and sine on the other side. So what do we do when we've got sine and sine? It means that we are going to apply our trig ratio. We are going to apply our what? We are going to apply our sine of x is equals to this one, right? Sine and sine, if they are equal, then what is on the right hand side here on inside the angle is going to be our reference angle, all right? So it means that I'm going to find my ref angle here, right? I'm going to find my ref angle there. So my ref angle is going to be sine second function of that one, sine second function of what? Of sine of 100 degrees minus 3x, all right? So it means that my reference angle is going to be 100 degrees minus 3x, all right? So now I can easily find my general solution, all right? So my general solution is positive here. Remember, there was no negative here, there's still positive here. Remember, when I do the general solution here, more especially, I check here. I don't even come and check on top there. I'll check here, all right, on the bottom there where I started to find my reference angle, all right? So it's positive, so it means that it's on the first quadrant and the second quadrant, right? So it's going to be what? It's going to be sine of x. Sorry, I no longer need to write sine. I don't know what I'm doing. There is no sign on the general solution, right? So it's going to be 2x plus 20 degrees is equals to first quadrant is going to be 100 degrees minus 3x, and then the first quadrant is this is exactly like that, right? And then it's going to be plus 360 degrees dot k, and then k is z, right? And then it means now I'm going to do what? I'm going to change what? I'm going to take the 20 to the other side and the 3x to the other side, right? So it's going to be 2x plus 3x is equals to 100 minus 20, they are all degrees, right? Plus 360 degrees dot k, and then k is and then it means that 5x is equals to 80 degrees plus 360 degrees dot k, and then k is all right? So now I can divide both sides by 5. So it's going to be x is equals to 80 divided by 5 is what? 16, right? 16 degrees dot plus 360 divided by 5 is what?
75.
75 degrees dot k, and then k is z. All right, so there we are. That is the first general solution. The next one is on the second quadrant. Second quadrant is 180 minus. All right, it's 180 minus, so it's going to be 2x is 2x plus 100, plus what? Not plus 100, plus 20, sorry, plus 20 degrees is equals to 180 degrees minus into 100 reference angle, 100 degrees minus 3x, and then plus 180 dot k, and then k is z. All right, and then after that we can write our general solution by taking the 20 to the other side, or let me just simplify. So it's going to be 2x plus 20 degrees equals 180 degrees minus 100 degrees plus 3x plus 180 dot what did I write? 180 dot k. Oh guys, I'm sorry here. It's 360, right?
So can
Yeah.
I ask,
Yes.
isn't 360 divided by 572?
360 divided by?
So I'm also getting 72.
360 divided by 5, isn't it 72?
Okay, I don't know, give me 75. I didn't use a calculator. Someone is saying they are also getting 72, so it means that the answer should have been 72 maybe. Yes, it should be 72. Now I can see it's 72, yes. Okay, thank you for that, right? Thank you for that. It was an error on the calculator. I don't know who gave me the incorrect answer, but obviously it's not something that we should be very much worried about, right? It's just a small error, but remember, it might make us lose a lot of marks, right? 360 degrees dot k, and then k is z there, right? And then it means that it's going to be what? It's going to be 2x, and then the 3x when it comes this side is going to be minus 3x equals to, on the other side, 180 minus 100 is 80 degrees, and then when you take the 20 to the other side, it's going to be what? It's going to be plus or minus 20 degrees plus 360 dot k, and then k is z, right? Okay, I think my iPad now is tired. It is starting to glitch, right? Okay, so it's going to be negative x is equals to, this one is going to be 60 degrees plus 360 degrees, right? 360 degrees dot k, and then k is z, and then now we are going to have what? We are going to divide everything by negative, so it's going to be x is equals to negative 60 degrees minus 360 degrees dot k, and then k is z, right? So there we are. That is our solutions, right? There is our solutions, right? So I think I've said everything about the general solution here. I don't think there should be a question that should not get it correct. Okay, so let me just quickly go to files, but my PC is glitching. I think it is tired. I don't know why. It's because maybe I've been using it since in the morning, right? So let's look at these examples here, all right? And then I will tell you what you were supposed to do here, and you will see exactly that. I think I've explained everything thoroughly, all right? I think I've explained everything thoroughly. So maybe on the questions here, if there is something that I feel like I've missed, then I will have to explain it before the end of this lesson, which have ended, right? The lesson have ended, but I just want to confirm here. So this is our trigonometry, yes. Okay. So where are the questions for general solution? Here they are. Proof, okay. Given trigonometric, okay. Prove the identity. Okay, given this one, proof for which values of x will this one. Okay, these ones here are also the general solution. For which values of x is the general solution, and then I didn't talk about it, but these ones here, let's talk about, let's see these ones, right? Let's see these ones. This one is the first one that we talked about in the beginning, right? Let me change the pen. Where is it? Okay, I can see it now. Okay. Okay, this first one here is the one that I started with also, right? That is the one that I started with also, this one here, right? And then we've got something like this. This one here, I did it also, where you just need to, where there is an angle here with something, you take it as a whole for general solution, all right? And then we've got this one here where we've got square root of cos of theta, and then cos of the sine of theta here. So this one, we're going to take sine to the other side and divide both sides by cos to get a tan, right? This one, there is no other way. We take cos, sine to the other side, we divide both sides by cos, and then the other will be sine over cos, which is going to be tan, and then the other will be just a number, right? And then this one here, I've got sine squared, and I've got sine x, and I've got 1. So this one, I can see that it's going to take 1 to the left, and it's going to be a quadratic, right? It's going to be a quadratic. And then this one also is cos and cos, so I can take to the other side, or I can divide both sides by cos. It's going to be what? If I divide both sides by cos, it's going to end up being 1 over 2, right? Cos squared of theta is going to be 1 over 2. But that is not good. To divide both sides is not good. It is similarly to this question, right? It is similarly to this question, okay? Or should I write it here? If you are to simplify and they give you x squared is equals to x, and then they say solve for x, and they give you what's wrong here. Oh, it's on a white, sorry. It's on a white. Okay, so if they ask you to do this, if they give you this question here and they say you are solving for x, right, they give you 2x squared is equals to x, and you are solving for x. You come here and divide by x, and then this one and this one you will have what, and then this one and 1x here, you have 2x equals to 1, and then you divide by 2, you divide by 2, and you are left with x is equals to 1 over 2. This is not correct. All right, this is not correct. In fact, let me not say it is partially correct, let me just say it's not correct. Why is not correct? X squared should always have two solutions, right? Once you have got x squared, it's a quadratic, it must have two solutions. So you have got only one solution there. There's one solution that is not there, which is a 0. You cannot divide by the you cannot divide by this one by cos of x and to take it away, right? To take it away, you cannot divide by it to take it away. All right, so it means that what we had to do there is to take 2 cos square of x minus cos of x, right? Cos of x equals to 0. Then you factor out cos of x, and then to have 2 cos x minus 1 equals to 0. So it means that we have got cos x equals to 0, or 2 cos x equals to 1. Then you divide by 2, then you've got cos x equals to 1 over 2. I mean for this one here, because I know some of you are going to divide by cos both sides. So once you divide by cos both sides, it means that you are throwing away one solution, which is cos of x equals to 0. All right. Similarly here, if it's a quadratic, if it's on equations, and then you just divide by a variable. In fact, do not divide by variable, right? So our variable here was cos x, obviously, so there was no need for us to divide by cos x. But on this one, we don't have any other option. The only option that we have here is to divide by cos x both sides, right? So this one here, you do not divide. I told you what to do, right? Okay, so let's go to the next one. Let's go to the next one. The next one is going to be what? Okay, 1, 2, 3, 4. We've talked about 5. Let's go to 5. Okay, 5 here, or 5 we talked about also. I said it's quadratic, right? So it's going to be 2 sine x, right? It's going to be 2 sine x, 2 sine squared x minus sine x minus 1 equals to 0. So you can use quadratic equation, is fine, or you can factorize if you can, right? So you can use quadratic equation, or you can factorize on this one. So let's talk about this one now. This one is cos and cos. So I told you, if cos and cos, this one becomes your reference angle as it is, right? So you're going to use this one and this one as the reference angle, and then you're going to simplify, right? And then let's go to the last one. This one is a cos and a sine. So they've got two different angles. So once they've got two different angles, it means that this one is going to be what? Number 7. You are going to change the sign to be cos, right? So it's going to be cos of theta plus 30 degrees equals to cos of what? Cos of 90 degrees minus 2 theta. All right. So there we are. So 90 minus 2 theta will be your reference angle. Then you work your general solution. All right. And then we'll talk about this one. This one we've got 2 cos of theta, and then we've got 5 cos of theta, and then we've got cos squared of theta. All right. So this one here is different. This one I told you, grade 12 is for you. It means that you have got a double angle there. It means that you are going to expand a double angle here of cos. All right, you're going to expand a double angle of cos, and then remember, because you only have cos here, there is no sine. So it means that this double angle of cos, when you expand it, make sure that you don't have a sine. So it means that's going to be 2 cos squared minus 1, right, instead of the one of the other two that have got sine on them, because you cannot have all these causes and only one sine and believe that you're going to be able to solve there. You won't be able to solve, right? So for grade 11, this one won't come. For grade 12, it will come, and then if it comes, then you have to expand your double angle of cos in a way that you will only have cos, you won't have sine, and then you can simplify. I will clear them.
Yes, sir.
Yes, sir.
Okay. So that is the end of the lesson. I said everything about the general solution. I thought maybe when I look at the questions here, organized question here, I will find something that it didn't explain. So I realized I have explained everything. So this is the questions that I'm giving you. You just go and try them, right? Just go and try them. So let me just send them to you, to all the groups. Just go and try them. And then the memo of these questions, I'll post it on YouTube. I think my Wi-Fi tomorrow will be up, guys. I was not having a Wi-Fi all these days, right? I was using my own data. I didn't have Wi-Fi all these days. That is why I was not posting on YouTube regularly, right? I've done a lot of videos, but I haven't managed to upload them because due to data, right? Okay, so I'm going to send this to all the groups. Guys, let's go and prepare for our examination and do our level best. Let's call it a day sharp.